Okay, so here we go. We're answering questions from the homework. We're answering questions from the notes. We're finishing the questions from from the homework and the notes together in preparation for the quiz, okay? Our goal is to be able to graph all these pieces without the aid of a calculator. Here we go. There is a progression that I feel is probably your best approach, and you can take a picture of this after we finish showing the list, and if it works for you, use it. I think it will work for you. And here are the steps. Number 1, you factor. Number 2, you're going to identify the removable discontinuities, otherwise the holes in the graph, okay? And that's the pair. Whenever there's a binomial on top, that's the same as the binomial on the bottom, that cancel, okay? Step 3, the leftover scraps in the denominator are the VAs, okay? And those are like x equals a number, okay? And then number 4 is going to be the HA, okay? And you're going to look at the original equation to see what would that be. Y equals a number or a graph. This is that Bobo Botan eats ratio stuff, okay? And then last but not least, we have the x-intercepts and the y-intercepts. So let us begin. If I factor number 5, what do I get in the numerator? Yep, x minus 5 and x plus 5, because it's a difference of squares, okay? If I factor the bottom, what would that be? X plus 4, yep, x plus 4, x minus 4. Step 1 is done. Step 2, identify the removable discontinuities. Are there any removable discontinuities right now? No, because you don't see a pair that could cancel out. So you're going to put none way over here on removable discontinuities, and you're good. So this next step is to identify the vertical asymptotes that will be found from the denominator. What are those? Who can tell me? Yep, so we're going to say this one is x is equal to -4, because remember, you're setting each of these things equal to 0, and this would be a +4. So you could say x equals a -4 and x equals a +4. Okay? All right, next thing we're going to do is the horizontal asymptotes. So the horizontal asymptote I'm going to label in orange, because that's going to come from the original function, okay? Not the factored form, but the original. It's easiest to see Bobo Botan eats ratio, okay? What's the degree of the numerator? 2. What's the degree of the denominator? So Bobo Botan eats ratio, which one of those 3 things does this reflect? Eats ratio. So now it's the ratio of the coefficients. What would that be as my horizontal asymptote? 1. Yep, y equals 1. Now listen. You will either have a horizontal asymptote or a slant asymptote or an in-behavior asymptote. An in-behavior asymptote is, if it's x squared, it'll be a line that looks like this. If it's x cubed, it'll be, not a line, but a graph that looks like this. You with me? In-behavior means quadratic and up. You with me? Slant is just, there's a difference between the top and bottom by 1 power, which makes it an x to the power of 1, which is a line. Okay? So again, let me remind you, horizontal, it will either have this and none here, or it will have none here for the horizontal, and you'll see the equation right here. Okay? Not both, but just one or the other. Alright, so now that we've identified the horizontal asymptote, the last thing is we're going to go to x-intercept and y-intercept. How do I find my x-intercepts? Oops. What do I do for my x-intercepts? Set the numerator equal to 0. So this numerator over here, let me color coordinate it with blue. this numerator will give you all your zeros of the function. Otherwise, where it crosses the x-axis. Okay? So we're going to put x is equal to what in the order that you see it? 5, negative 5. Alright, and then the last one. Y-intercepts. I'm going to color coordinate this as orange also, because these two are really the only ones that you should be using the original one with. Because for y-intercepts, it's when I'm setting x is equal to 0. So if I plug in 0 here and here, I'm left with this number, this weird number of negative 25 over negative 16 is my y-intercept. And that's like what, 1 and 9/16? You know what I mean? So 1 and 9/16 is a little bit over 1.5. So let's put our y-intercept there. Our x-intercepts are at negative 5 and positive 5. My vertical asymptotes, we're now drawing it, are going to be at x is equal to 5 and x is equal to negative 5. I'm going to have to move these a little bit after this shifts. Okay, so x is equal to, oh my bad, 4, negative 4. So there's negative 4, and this one is at positive 4. Alright, what else do I need to graph that I haven't graphed yet? Horizontal. And what's the horizontal asymptote? Y equals 1. Okay, so let's grab the line, and we'll do it somewhere around there because it's going to shift. And let me shift it down at y is equal to 1. Okay, anything else that we haven't graphed yet? That's it, right? So now, the last part of this, guys, is to figure out, let me make this a little bit better, is to figure out what the rest of the graph is going to look like. And we're going to do that with a sign test. Okay? So we're going to test some signs here. So everything where the top and the bottom equals 0, those all numbers are going to come over here on the sign test. And this is the last thing that we are learning in regards to how to graph these all by hand with no calculator. Okay? So what numbers am I going to list? 5, negative 5, bless you, negative 4, and 4. So we are going to test 5 different intervals because we had 4 different zeros. Whew, bless you. Let's look at what we're going to test. Here we go. I'm going to throw in a negative 6, negative 4.5, 0, 4.5, anything in that interval, and like a positive 6. Okay? And where I'm going to throw these into the equation, let's draw a negative 6, is everywhere where you see an x. Okay? Here we go. All I care about is the sign. I don't care about what the number is, I just care about the sign. If I throw in a negative 6 right here, what does it make this when I throw it in there, right there? Negative 6 minus 5 is a what? Negative. It's a negative, right? That's all we care about. Throw in the negative 6 here, and what do I get? Negative. How about here? Negative. And finally, if I throw the 6, the negative 6 there, what do I get? Negative. What does all this give me if I multiply and divide? Positive. That's all I care about. And a positive means it's above the x-axis, not above the horizontal asymptote, which some people mistakenly were doing earlier today. It means it's above the x-axis. Okay? Here we go. Let's now do negative 4.5. So here we go through the signs. The first one is negative. The second one, positive. The third one is negative. And then the fourth one is negative. So what would all this give me? negative. You with me? Alright, next one I'm going to do is very easy. It's just 0. So what am I going to get here? Negative here, positive here, positive, and here, negative. What does that whole thing give me? A positive. Because if you have an even number of negatives, they positive out. Okay, they cancel each other out to a positive. Let's do 4.5. What's that? Negative. And then here, positive. Then here, positive. Yeah, you're right. It's a big positive. It's like 8.5. And then here, a positive 0.5. So what does all of that give you? A negative. And the last one is everything is, I'm going to have 6 plugged in. And what would all of these values, when I plug in 6, what would they all be? Positive. So now look, I'm going to highlight it and color coordinate it. Everything that is above the x-axis is positive. Everything that is below the x-axis will be negative. Okay? Here we go. So the graph for the first interval from negative infinity all the way to negative 5, it's going to be positive. So here we go. Notice how I hugged the horizontal asymptote just like we did with that near pod activity. Okay? The second interval is now going to be negative. That means from negative 5 to negative 4, I need to be below the x-axis, approaching the appropriate horizontal or vertical asymptotes. The boundaries, pretty much. And then now I'm positive between negative 4 and 4. The only way that can happen with hugging the vertical asymptotes and also going through that y-intercept that we found would be looking like this. Then from 4 to 5, I'm below. So from 4 to 5, I'm going to be below, approaching that x-intercept that we found earlier. And last but not least, above the x-axis, it would look like that. And everything is satisfied. Are we good? Alright, so now let's answer some questions. Okay, we're going to answer these questions down here. So there's not a slant here because exponents are the same. So it was y is equal to 1.
Oh, so like if there's something there, it's a 9.
Yeah. So if you have a horizontal, the slant is none. Okay. Now, let us highlight the graph in blue. And that represents all of these f of x's. Because that's what they're describing. They're describing the function where it's defined. Okay? Now here we go. This first one here says, I want you to approach negative infinity. So guys, I'm going to make it a little bit obvious. I want to approach negative infinity. You with me? So if I'm going to the left and I jump on the graph, what y value would the graph want to hit? 1. So you're going to put a 1 right as your answer. You see how I'm doing this? Alright, the infinities are a little bit easier. It's the other ones, but let me warm you up with the infinities. Now, the next question says, what if I go to a positive infinity, which is right here? That means you're just going to go to the right. What will the graph, if you jump on the graph, what will it approach? It'll approach 1. As x approaches infinity, f of x approaches 1. It's like zeroing out, you know what I mean? Leveling out. Now, here we go. These are a little bit different, okay? So that one's 1 and this one's 1. Now we're going to approach negative 4 from the what? From the left. Guys, this little symbol, this negative sign after it says negative 4, okay? let me do it a little bit smaller so you can see it. This negative sign right there says you're approaching from the left. Watch how I do this. So here's -4, and you're going to approach that from the left. So if you jump on the graph, where is it going to take you? To -infinity. Okay? Alright, so -infinity will be the answer right there. Now let's approach -4 from the right.
Why isn't it like approaching the vertical asymptote? Or like why isn't it? Because on the whenever it's going to the left, it's to 1, but like it looks like it's getting close to the -4 or -5.
I see what you're saying. You're trying to approach the vertical asymptote when you're looking at this, okay? So it's like you're zooming in and you're trying to get as close as you can, in this case, to a -4 right before you touch it. Okay? So let me show that again. If I'm approaching, down here it says -4, here's your -4, and you're approaching it from the right. That means you're going to get very, very close to x is equal to -4. So from the right, you're coming over here. So it's like you're envisioning, you're coming from the right. Where would the graph go? If you're right before you hit -4, where's the graph going? Positive infinity on this. Because on the graph, it was showing it was going up to a positive infinity. Okay? Alright, now let's approach +4. Don't get them confused. +4 from the what? From the right. What would that equal? -infinity. Okay, this is positive infinity, or sorry, this was +4, and I'm approaching it from the right. And again, the blue part is my graph, and you see it dip down and go downward as far as to -infinity. And last but not least, approaching +4 from the left, what would that be? Infinity. Yes?
So, how can you, like, what are the signs? Because that's just what I'm confused on. What signs indicate, like, which side it's coming from?
Okay. So if I were to say, I want you to approach 5, okay? 1, 2, 3, 4, 5. Here's 5. Okay, and wherever it is on the graph, it's basically saying anywhere where 5 is at, if I approach from the right, that means I'm coming from this way.
Okay, so plus will be coming from the right,
Mm-hmm.
negative will be.
And negative, yeah. So if this was like x approaching 5 from the left, it's approaching 5 this way. Are we good? Alright, what other example from the homework do you all want to work out right now? Or even from notes? More so from homework because that's what I know you have the questions on.
Number 8.
Number 8. Okay. So number 8 is saying write down the equation for the vertical asymptotes and use long division to determine if it has a slant or in behavior. With dotted lines, draw them, sketch them, and then with the aid of the calculator, graph it. So this is saying, guys, with a calculator, you want to see what does this finally look like at the end. The only thing I want you to discover by hand without a calculator are slant asymptotes and vertical asymptotes. Okay? Here we go. The difference here is what? Because I give out a lot of participation points today for good answers. What's the difference than what we just did? It's bigger on top. So this is bottom. So this isn't Bobo, because if it was Bobo, bigger on bottom, y would equal 0. So this is bigger on top, which means there is none. There is no horizontal line that the graph will approach as you go to infinity or negative infinity. Guys, if there's no horizontal line, that means you have choices. It could be a slant asymptote going up or down. Or it could be a quadratic in behavior asymptote. It could be a cubic asymptote. It all depends upon how much bigger is the power from the top compared to the bottom. You with me? What's the difference here? 1. So that means it's going to be a line, because it's like x to the power of 1. If the top's at 2x cubed, then it would be 2 differences. Then your asymptote, in behavior asymptote, would look like this. You with me? And then if the top one said x to the 4 and the bottom said just x, the difference would be 3. And that's what your asymptote will look like as far as your in behavior asymptote. Are we good? All right. So, with that being said, remember, it will either have a horizontal and none of these, or it will have none as far as horizontal, so it won't have this, and it will be one of these, whatever they are, as far as, you know what I mean, as far as the answer is concerned. All right, so bottom is the big thing. And because it's bottom, what I'm going to immediately do is do long division or synthetic division. And in this case, I'm going to do long division because the only time you can do synthetic division is if it's x minus a number or x plus a number. Those are the only 2 times that you can do synthetic division. You with me? So it has to be a positive 1 coefficient for you to be able to do synthetic division, otherwise you can't. So we're going to do this long division wise. Here we go. 2 terms, starting here, right above the 11x, what would multiply with this first term to get that first term? X over 2, so x over 2, a negative 1, right? A negative x over 2, you see that this is going to be pretty involved, right? Like already you're like, whoa, we're not used to seeing fractions like this. You with me? So what you could also do from the very beginning is you could factor out a negative 2, and you would have something that looks like this for the top. Okay? Then you could factor out 2 on the bottom, so that these 2's cancel, and you see the remaining pieces of the VA would probably be at 3/2, because we're going to set that piece equal to 0. So at 3/2 is where that VA would be. You with me? Okay? So here's what I'll say. Number 8 is a little crazy, okay? You're not going to see number 8, but I want to just still experience it with you so that you know what you're trying to do and look for, okay? It won't be on the quiz, okay? Something that level of difficulty won't be on the test. But still, the approach is the same. So let's do another problem like this, but that's not number 8. What do y'all have? Number 9. Okay, good. And I appreciate y'all doing y'all's homework, because the questions that you are asking, I've already expected them, okay? And they're good questions, really good questions. All right. So, bottom. You see it immediately, right? So we're going to do 2x cubed plus x squared minus 3x plus 8. And we're going to divide it by x squared plus x minus 2. Watch the steps, because you will have something of a level of difficulty like this. 3 terms, starting right here above negative 3x. I need to ask myself, what will multiply with this to get that? What do you say? 2x. Okay, now let's multiply this out. We get 2x cubed plus 2x squared minus 4x. Subtracting this, be careful. Now I'm not going to talk you through this. I want to see what you know. Say it out loud. Do the 2x cubes cancel out? Yeah, to 0. How many x squareds do I have left? Not 1. Negative 1. Nice. Negative x squared. Because it's a positive x squared, and a negative positive means it's going to subtract. Okay? So you get a negative x squared. How many x's do I have? 1. Nice. And I bring down a positive 8. Good. Now we are going to ask ourselves, what new number will multiply to get the first terms over here? Negative 1, right? A negative 1. So a negative 1 will give me negative x squared minus x plus 2. And we are going to subtract the parentheses. Do the x squareds cancel? Yeah, they cancel to 0, right? How many x's do I have left? 2. Okay? Because, again, we need to remember, we're distributing this, so you're really adding an x. Okay? What's my final number that I'm left with? Plus 6. Guys, this right here is a remainder. Okay? This is a remainder. And the way we're going to do this is we're going to say our answer is 2x minus 1 plus the remainder of 2x plus 6 over our original divisor. Okay? And all that's important is this. And that is our slant asymptote. This over here, it's not important because this will all go to 0. And you'll learn that here soon. Okay? So we just need to graph 2x minus 1. So this minus 1 says that's where we're starting. And we're going to have a slope up 2 over 1, up 2 over 1 from here. Up 2 over 1, up 2 over 1. And it's basically going to look like this. This is your slant asymptote. Okay, you with me? You don't have a horizontal. Because this was bottom. It was bigger on top. Okay? Now what? Okay? What we were doing is we're trying to graph slant asymptotes and vertical asymptotes. Okay? So, what do? How do I graph a vertical asymptote from this original equation? What was step 1 that I gave you to the approach of to factor everything, right? So let's go back. All I did was right now practice with you so you could see long division to find this slant asymptote. Now let's go back to the other practice that we were doing. Factor so we could find immediately our vertical asymptotes. Okay? Here we go. So this will factor on the bottom to what? Like I'm trying to factor that piece. What are my first 2 terms, guys? Come on. X. Now, my last 2 terms will multiply to get the negative 2. And whatever I get with those numbers, these will end up adding to a positive 1. Plus 2 minus 1. Okay? So plus 2 minus 1. Now, I'm going to show you, I can see whether these are going to be holes in the graph or are they going to be vertical asymptotes like that, okay? And the way I can do it is using synthetic division. My original numerator is 2, 1, negative 3, 8. What I want to do now is I want to test x plus 2. So if I'm going to test x plus 2 to see if that's a factor of this entire numerator, what goes here in the box? Negative 2. Here we go. 2, negative 4, negative 3, 6, 3, negative 6, and this is 2. This is not 0. Because it's not 0, that means on the top there will not be a factor that is x plus 2 on the top, that you'll be able to say, oh, there's a hole in the graph. Okay? I didn't get a remainder of 0, so there will not be one of these factors. Okay, so let's test the other one, because we want to see, how about, is there a factor that is x minus 1 in the actual numerator? So, in my box, I'm now going to test x minus 1. What goes in the box? 1. Here we go. 2, 2, 3, 3, 0. And because this is not 0, we know that 2 is not a hole in the graph. You with me? So these are our vertical asymptotes that are left over. So let's graph these. How do I graph this? X equals negative 2. How do I graph x plus 1? X equals 1. And from there, because of the directions, we would plug this into our calculator and verify the rest of what the graph looked like. I was just wanting to make sure you could find the VAs and the slants or the horizontals without the aid of a calculator. We have about 15 more minutes to answer any last questions that you have.
How did you find the slope?
How did I find this guy?
Yes.
By doing long division with it originally. You know how I did the top divided by the bottom?
Yeah.
Yeah. And whatever I had left, which is this right here, that's what gets graphed. No remainder gets graphed. Okay? What else?
So if there is a slant or end behavior asymptote, there's no horizontal.
Perfect. You with me, guys? So let me do a better visual on that, because you weren't the only one that had that question. If you're looking at slant and end behaviors and horizontal asymptotes, it's all about analyzing bottom. Okay? If it's bigger on top, it will be no asymptote, like horizontal asymptote. There'll be a slant, or a quadratic, or a cubic, and so on and so forth. All of these are bottom. Go with me? Bobo, this is where your horizontal is. Okay? Why did I do haha? But anyway, so this is where your horizontal asymptote is. Okay? This is where it's bigger on top. If it's bigger on top by 1, it looks like this. If it's bigger on top by 2, it looks so on and so forth. You cannot have this and one of these. If you have an HA, that means you do not, and you will not have anything else. You with me? Not even this over here where it's exponential. Sorry, exponents are the same, the ratio. If you don't have a horizontal asymptote, if you don't, it means you will have one of these, one or the other of those. Okay? So from this list of Bobo-Bonnet's ratio, you're only going to have one of them. Either the y equals 0, or these, or your ratio.
How do you plug this into the calculator to get like the graph?
Just you put it like the function looks like this. Go to your graphing calculator, and then just press tab, control, divide, and then you're just going to put it right there where the graph says f of 1. Everything will be there. Cool? What else? Any more? Yeah.
Is there like a certain number of numbers that you have to test for the science test?
There's not a certain ones, just everything where the top equals 0 and everything where the bottom equals 0, those are all the ones that you're going to test. Okay? All your factors where they're 0. What else?
How do you find where it's undefined?
Okay. This is a really good question. What makes something undefined? Denominator 0. So it could be it could be whatever is on top. So if you have a fraction, whatever's here, this equals undefined. So all your denominator, removable discontinuities, vertical asymptotes, it doesn't matter. They will all be undefined. And that's what the domain does not exist. Yeah.
Do you think we have enough time to do number 10 just to see how synthetic that would be?
Sure, yeah. You said number 10?
Yes.
Okay. Perfect. So let's look at synthetic division in action. We have -1, 8, -17, 12. What goes in the box? 2. Here we go. So I copy and I get -1. And then? Yep. -5, right? And then? -30? Oh, my bad. You're right. Man, you caught my mistake. Good. So -10, so the answer is 2. Because I have a remainder, that means I know that an x minus 2 will not exist in the numerator. And if it doesn't exist, that would cancel to a hole in the graph. That leads me to believe that this x minus 2 has to be a vertical asymptote at x is equal to 2. You with me? Now, good timing on this question too. Thank you, Jacob. This remainder would be written like this. So constant x, x squared, x cubed. That was the original. It shifts over constant x, x squared. So you have this. Bless you. Gosh, you scared me. Plus 2 over the x minus 2. Guys, this is your reduced quadratic after you synthetically divided. And this would be the leftover stuff that, that you would have. It would look like this. Okay? This that's written in blue, that's what you draw out. That will be your end behavior asymptote. So think of it like a horizontal, think of it like a slant, but now it's a quadratic. Okay, so let's go ahead and graph this real quick. Okay, so we have -x squared. What was the rest?
6x
Minus 5. So this is where the actual graph would be with the dashed lines, showing where the graph would not exist. You with me? So if we were to graph this, let's go back. 1, 2, 3, 4, 5. So 1 and 5 at about 4. 1 and 5 at about 4. So 1 and 5 at about 4. This right here would be your end behavior asymptote that the graph would approach but never hit. Okay? Now let's look at the graph. If you guys can tell me the original equation, I will show you what it looks like over here as far as on the graph, okay? So, what is the original equation? Hold on. Alright, go ahead. Okay? Plus 8x squared.
Minus 17x.
Okay, so, minus 17x plus 12. Over. See, that's where the graph would be. Everything that you see blue right now would actually be your horizontal asymptote. Okay? So if I zoomed out, said this was the center, everywhere that it's blue would actually be the horizontal asymptote, like interpretation. You know what I mean? So you would do like this everywhere where it was blue. And it's the graph that the red function approaches as it goes to negative and positive infinity. And that's the culmination of understanding. Questions? Yeah. Oh, yes. You didn't have to ask that in the recording.